welcome to Diksha Vedantu. I hope you all are doing great. I'm your Aditi Mam, and today in this lecture we are going to start the chapter Chemical Reactions and Equations, the very first chapter of your class 10th and one of the most important ones. We all know a big question will come from this chapter about balancing or about different kinds of reactions, right? So we are going to see all in this chapter, and beta, if you just go through the theory and does not do questions, that chapter is probably of no use. So in this video we are going to see a lots of questions of balancing, a lots of assertion reason questions, MCQs, all in just one video. And I can guarantee you, if you see just this one video, your PT tests, your half yearly, your pre-boards, boards are completely sorted. Okay, so let's quickly start this chapter. And beta, the very first thing that comes into our mind is, of course, ma'am, what is a chemical reaction, right? So beta, whenever you make a chai, right, you take few ingredients, you mix them together and you make a final product. So what is happening? You are giving it temperature, you are mixing 2 or 3 ingredients, you are letting it boil for some time, its color is changing, its temperature is changing, some gases are coming out of it, right? So all those things all those things come under a reaction. Yes, even a tea, even a simple process of making a tea is actually chemistry and science. Okay, so let's see the definition of chemical reaction from a scientific point of view. Now in this whole chapter, what we will be learning is obviously about chemical reactions, chemical equations, how to balance them, different kinds of chemical reactions, and lots of other stuff that I'll tell you as we move forward. Right now, starting with what is a chemical reaction, beta. So what did we do while we were making chai? We combined 2 or more substances, water, milk, tea, sugar, or if you use jaggery. So we combined all of that, and the whole process of combining these 2 or more substances and then transforming it into a new substance is called a chemical reaction. A process in which 1 or more substance is changed or transformed into a new compound with the new chemical properties. Now, of course, chai tastes different than water. Tea tastes different than just sugar. So the chemical properties are changed, the taste is changed, the temperature is changed, the color is changed. So when we combine 2 or more substances and it is transformed into a new compound with changed chemical properties, new chemical properties, that is called your chemical reaction. Now beta, a very basic question comes here, that why we talk about rearrangement of atoms. Okay, now a very basic thing is, I am made up of atom, you are made up of atom. No, then why you look different than me? Why this camera looks like a camera but I look like me? Because of the rearrangement of different kinds of atoms, right? So atoms are rearranged in tea leaves, in sugar, in water, in a different kind of manner. But when they got converted into tea, the rearrangement happens. The arrangement of atoms changes, and hence we say that chemical reaction is also called rearrangement of atoms. Done? Basic example is calcium plus oxygen gives us calcium oxide, right? Now beta, in this whole reaction, when we talked about chai, when we talked about sugar, when we talked about leaves, what is happening? We got tea plus sugar, right, plus water plus our milk, right? So all these components that mix together in the first place, these are called reactants. We all know this by this time, I hope. I am assuming that you know this, but I'm still telling you, okay? And the final product that is being formed, that is your tea, right? This, let's not write this tea, let's write it tea leaves. Okay, so this on the product that is being made, that is our product. Okay, so the substances that combine are called reactants. The substances that is finally being made, that is called your product. Done? Okay, moving on, next we have characteristics of chemical reaction. Now what happens when you make tea? Its color is changing, right? Its temperature is changing, so some gas vapors are coming out of it. So all these are what? These are characteristics of chemical reaction. What is happening when two or more substances are combining together, right? So what can happen, beta? Change in state. How, ma'am? Okay, so you did what? You got milk, you boiled it and you forgot, and you kept boiling it, all the water is evaporated, a thick condensed milk is there, and now it is not completely liquidy, completely watery, right? It's a jelly like substance, and if you freeze it, it becomes very thick, right? So what happened in all this process? Change of state from liquid to what? It became solid. From liquid, I don't think it is visible. Okay, from liquid to it became solid. So what is happening? Change of state is happening. And we also know naphthalene balls. When you keep naphthalene balls in the air for some time, they evaporate. Okay, we call it sublimation, right? So what is happening? Naphthalene balls are changing their state from solid to direct vapors. Liquid does not come. That's a fascinating fact. Okay, so in that thing, what is happening? Change of state is happening, right? Next beta, change in color. When you keep boiling the tea, it gets darkened, then a lot darkened, then it gets maybe black. If you keep boiling it, what is happening? Change in color is happening, right? And of course we are giving it heat, so change in temperature is happening, right? And some water vapors are coming out of it. That we cannot see evolution of gas. We'll see evolution of gas a little later. So basically there are some reactions where hydrogen is released or carbon dioxide is released. So all these are what? These are gases. We'll study about this, don't worry. Okay, next beta, moving on, and these are a very important point. Characteristics of chemical reaction. What is happening? Change in state, change in color, change in temperature, evolution of gas. Done? Understood? Okay. Now beta, next we are talking about what is a chemical equation. Now why is the need to talk about chemical equation? Let's understand that first. Okay, so beta, this is our chemical reaction, right? What reaction is happening? But I have to write it down on a paper, right? So how will I write it down? If let's say my reaction now is, let's say I'll take an actual example of a reaction, that is your calcium, okay, plus oxygen, and it gives us what? It gives us calcium oxide. Now how much time it took me to write this whole sentence, right? What if I just did Ca plus O2 gives 2CaO? I'll tell you why this 2 is there, right? So what is this? What is happening? We are writing our chemical reaction with the help of some symbols, the symbols of these elements. Okay, so that is exactly what is happening here. To represent the chemical reaction onto a paper with the help of symbols is called beta chemical equation. So a chemical equation is the symbolic representation. We represented calcium with the help of Ca. We represented oxygen with the help of a single element O or O2, right? Of a chemical reaction. Now it can be written in 3 different kinds of forms. First is what? The word equation. The one I wrote here. This one is what? This one beta is what? This one is simply a word equation. I wrote down the exact spellings of calcium, right? But it can also be written as skeletal equation, as we call it. What are those? These, see, symbolic representation. So these are symbols. Hydrogen written as H2, oxygen written as O2, water written as H2O. Understood? Water is made up of these elements, hydrogen and oxygen, right? So we can write water as its chemical formula H2O. Done. Then beta, there is third thing as balanced chemical equation as well. Now ma'am, what is balanced chemical equation? See, when you say that water is there or tea is there, let's say, so you are making tea, right? And you say if you put more water, more amount of tea will be there. If you put more milk, more amount of tea will be there. If you put less milk, if you put less water, if you put less sugar, the composition, the taste of tea, that is the characteristics of our final product, that is tea, it changes, right? And it depends on the number of products, number of reactants we are using. The amount of product should be equal to the amount of reactants, right? The amount of product made, beta, should be equal to the amount of reactants that we used to combine to make this product. Now, there is a very interesting question that nobody tells us and nobody asks, that why? And it's like common sense, of course, yes, but there are some water vapors as well. So if you go and if you see the volume of tea, it's definitely less. But if you combine the volume of tea, the final product, with the volume of water vapors that evaporated, then it might be equal. But why? Have you heard about the law of conservation of mass? The law of conservation of mass. That means, beta, whatever mass of things, of reactants we are using, it should remain conserved. It should remain preserved, right? That's the one important thing that is very, very, very useful when we give a reason that why an equation should be balanced. Okay, now beta, talking about moving to the actual balancing of the equation. Now you can just skip this slide for a second and let me show you how to balance a chemical reaction. Let's just go here on this slide. Okay, now beta, I told you why the chemical equation should be balanced. That part is done. But how to balance the chemical equation? That's the main part. Right? Now beta, see, you are given a chemical equation. Iron plus water gives us iron oxide plus hydrogen. Done. Very, very, very simple equation. Let's just write it down again and see how to balance this. This section of the video is very important because a question of 2 to 3 marker or a question of a part of this balancing equation in your 5 marker question can also come. So make sure you know how to balance the chemical equations before you jump on to number of chemical equations and all that stuff. Okay, so first we are going to see how to balance this chemical equation. Now let's write it down first. Iron plus water, Fe plus H2O gives us Fe3O4 plus H2. Okay, this is the given thing. So when this equation is given, what is the first step you're going to do when any equation is given, right? You are going to make a box. Yes, that's it. And write, okay, divide this into 3 columns. Done. Write reactant, product, and here we will write, I'll tell you what. Now beta, what you have to do, see, there is one rule that you have to follow. Okay, so when we are balancing chemical equation, what do you think? What should I balance first? Iron or hydrogen or oxygen? Ma'am, what do we want? What do we feel like? That's not the way science works, right? So we have to be very specific on what do we balance first. So beta, on the very first part you have to balance metals. Okay, ma'am, what are those metals? Those metals are sodium, potassium, your silver, your copper, magnesium, zinc, calcium, iron, aluminium, manganese, lead and barium. Done. These are some of the metals. What then beta, on the second point you are going to balance non-metals. Those are what? Calcium, chlorine, bromine, sulfur, nitrogen, carbon and your phosphorus and a lot more we have. Then beta, we are going to balance oxygen and then hydrogen. Okay, done. Let's try to do it. how will we do it? See, now beta, out of these, which one is the metal? Ma'am, iron is the metal, right? So on the first, I will write iron here. I will write iron here, okay? Then we don't have any non-metal, so we'll simply jump on to oxygen. So I'll write oxygen here. Then hydrogen, I will write hydrogen here. Then what you have to do? See, write the number of elements present in the reactant side. So in the reactant side, iron is only 1, okay? Iron is only 1, right? And in here, beta, iron is 3. Iron is 3, so I will write 3. So these are not matching. We have to match those, right? That's how you know. That's how you understand, right? Okay, then oxygen. Okay, ma'am, oxygen is again 1 here, but here oxygen is 4. What? Then we have hydrogen. Hydrogen is 2 here. But here hydrogen is also 2. Okay. So we don't have to balance at least hydrogen. Then now that you have written everything, now how to proceed with your balancing? That's the main part. Now beta, what will we balance first? Your metal, that is your iron, right? So beta, on the reactant side 1 iron is there, on the product side 3 irons are there, and I was like, I will divide this product side iron with 3. Can I do that? I can't, okay? You cannot divide in the balancing of chemical equations, right? You can always multiply with the whole numbers, okay? So beta, I can only multiply this with 3. So 1 into 3 is 3. So basically what I'm trying to say, I am taking 3 elements of iron. 3 elements of iron in reactant, okay? And then only I will get Fe3O4 and these products and reactants will be balanced, okay? Then beta, oxygen is 1. Here it is 4. Again, if I multiply this with 4, will I get 4 oxygen in reactant side? 4 oxygen on the product side. So I will multiply. Can I do this? No, ma'am. In the foot, you cannot apply by yourself. That is nature's work. What you can do is write it in front of it. In front of the element, okay? Now you see one thing, ma'am, we have done the balancing, but there is one mistake that is left. That is beta, in attempting to balance oxygen, so oxygen is 4 here, oxygen is 4 here, but in attempting to balance oxygen, we unbalanced hydrogen. Ma'am, how? See here, 4 into 2, hydrogen is now what? 8 hydrogens are there. So here now not 2 hydrogens are there. 8 hydrogens are there on the reactant side. So now I have to balance the hydrogens on the product side because I can't actually divide. So what will I do? 2 into 4. 2 into 4 will be 8, right? So I will write 1, 4 here. So is this balanced now? Watch clearly, see clearly. Okay, iron is 3. Iron is 3. Balanced. Okay, hydrogen. Okay, next is oxygen. Oxygen is 4. Oxygen is 4. So iron is balanced, oxygen is balanced, and hydrogen 4 into 2, 8 hydrogens. 4 into 2, 8 hydrogens. Understood how the balancing works? Okay, let's try one more example. What is this given? Al2O3 plus HCl. What is this? Al2O3 plus HCl beta. It gives us AlCl3 plus water. Okay, now beta, you have to balance this. I'll give you pause this video and try to balance this chemical reaction and let me know in the comment section by the timestamp. What is the timestamp? You write the timestamp and let me know in the comment section. Write down the slide number. Okay, we go by slide number. Slide number 12. Write down the balanced chemical equation. Done? Okay, be very honest. Right now we are preparing for exams, we are preparing for tests. Okay, done. Now let's again try to balance this. Now beta, again what we'll do, we'll make a table. Okay, let me use these lines, it looks better. Okay, now beta, what again? Write reactants, products, and here first I will write metals, then I will write non-metals, then I will write oxygen, then I will write hydrogen. This one is clear. Now let's go back to the chemical equation. This is all the things you have to do before even starting the balancing. Okay, now beta, what are the reactants? Let's write. We have aluminium, of course, it's a metal. Okay, then we have chlorine. Chlorine is what? Of course, ma'am, it's a non-metal. Aluminium, metal, chlorine, non-metal, and then we have oxygen, and then we have hydrogen. Easy peasy. Right? Now, how many aluminiums are there on the reactant side, ma'am? 2 aluminiums are there, ma'am. 2 aluminiums are there. So, I will write 2. Try to write it down on the left hand side of the column, because you have to cut, you have to multiply, right? Then, beta, what number of chlorine on the reactant side, ma'am? Only 1. Then, oxygen, 3 oxygens are there. Hydrogen, only 1 hydrogen is there. Done. What are the number of products we have? Number of elements in the products. Aluminium, ma'am, it's only 1. Oh, chlorine. Chlorine is 3. Oops, we have to balance these. Then we have hydrogen. Hydrogen is 2. Oxygen is simply 1. So, technically, nothing matches. So, we have to balance everything. But, how will we balance that? Ma'am, very easy. You have told us how to balance. We'll do exactly like that. Now, beta, aluminium. 2 aluminiums are there on the reactant side. 1 is on the product side. What will we do? We multiply 1 with 2. 1 into 2, 2. So, multiply with 2, we will get 2 aluminiums on the product side. Done. So, I will multiply 2 with here, 2 with here with aluminium to balance aluminium, right? But what happened? In attempt to balance aluminium, every time you balance something, you go back that have you unbalanced something else. In order to balance aluminium, we unbalanced chlorine, right? So now chlorine is not 3, it is 2 into 3, cut it, write down 6. Done? Okay. Now aluminium is balanced, 2 here, 2 here. Chlorine is 1 here and 2 into 3. 6 chlorines are there in the product side. So I will do what? I will multiply this 1 with the 6, and that is your 6 chlorines, right? So can I write 6 here? In between H and Cl? No, I can't, because H and Cl is one compound. If I want 6 chlorines, I will have to get 6 hydrogens with it as well, because it's a combined compound. Okay, so I will write 6 here. That is your 6 HCl. Okay, so chlorine is 6, chlorine is 2 into 3, 6. Aluminium is 2, aluminium is 2. But what did we do? In attempt to balance chlorine, we unbalanced hydrogen. Now, hydrogen is not 1 here. It is 6 on the reactant side. Done. A little bit lengthy it can be when you start, because I'm teaching you, it can be seen as a little lengthy task, but when you sit down, when you do it, practice it 1 or 2 times, third time only, you will see that you have gotten very fast. Okay. Okay, even though we unbalanced hydrogen, we still have to go and balance oxygen first. Don't try to balance hydrogen now. Oh, hydrogen is unbalanced, let me balance it first. No, we still have to go in the order. We still have to balance oxygen first. Okay. Okay. Next, beta, oxygen is what? 3 oxygens are here on the reactant side. Only 1 is here on the product side. So what will we do? I'll multiply 3 on the product side, and 3 oxygens will be there, right? And both of these will be balanced. But where should I write 3? I will write 3 in front of H2O. I will write 3 in front of H2O, right? Now, again, be very careful that while balancing oxygen, I unbalanced hydrogen. 3 into 2, now 6 hydrogens are there on the product side. So, 6 hydrogens are there on the product side, and hence beta, we didn't even need to balance hydrogen, it balanced itself. Okay, so see, aluminium 2 on the reactant side, 2 on the product side, balanced. Chlorine 6 on the reactant side, 6 on the product side, balanced. Then we have oxygen 3 here, 3 on the product side, balanced. Hydrogen 6 on the reactant side, 6 on the product side, and hence balanced. And how colorful it looks, right? Understood? So if you are noting this in your fair notebook, in your perfect notebook, then I will suggest that you also use some kinds of colored pens, so that when you come and revise it, you'll understand it better how you did it. Okay, make sure to cut these so that you know that these got unbalanced while we were balancing something else. Okay, done? Okay, great. Next beta, let's see some more equations that need to be balanced. I know, but you need to practice. Okay, if you are not practicing, you won't be able to do it in the examinations. 1 or 2 questions are not enough. So I told you, you will get everything in this particular session. So you will get everything in this particular session. Okay, again, the first thing is to make a table. Okay, then write down reactant side, product side, make 3 columns. Done. First we will be writing metals, non-metals, oxygen, hydrogen. Okay, now ma'am, we don't even have hydrogen, so let's just remove this and we will write metals, non-metals and oxygen only. Done. Now beta, copper of course is your metal. Okay, sulfur of course is your non-metal, and then we have oxygen. Done. Now beta, how many elements of copper are there on the reactant side? 2 here, 2 here. 2 plus 2 what? 4 elements are there. And here, oh ma'am, only 1 element is there. Then sulfur. Only 1 element of sulfur is there on the reactant side. Only 1 element of sulfur is there on the product side. Okay, we might not want to balance this, right? Then oxygen, 1 element of oxygen is here. 2 element of oxygen is there on the product side. That is your table. Done. So copper is unbalanced, oxygen is unbalanced. What will we do? Ma'am, we will try to balance it. Okay, now we know, right? Okay, so copper, beta, what will I do? I will multiply this one with 4 and 4 coppers will be there on the product side, right? So I will simply multiply this copper with 4. Done. Copper is balanced. Copper is balanced. And I did not unbalance anything else while balancing copper as well. That's just an added benefit, right? Okay. Next beta, we have non-metals. Sulfur. Okay, ma'am, this is balanced. We don't need it. Oxygen. 1 oxygen is there on the reactant side, 2 on the product side. So I will do what? I will multiply this 1 with 2, right? So there will be 2 oxygens on the reactant side. So how will I do? Ma'am, I will multiply this oxygen with 2 on the reactant side. So oxygen is also balanced. Ma'am, done. Did you find the mistake? Yes, exactly. Beta, in trying to balance oxygen, we unbalanced copper, right? We unbalanced copper. This is 2 here, 2 oxygen is here, 2 oxygen is here, 1 sulfur is here, 1 sulfur is there. But see now, 2 into 2, 4 copper is here, plus this 2 copper is also here. So 6 copper is here on the reactant side now. So here 6 copper is there. So what will I do? I can just change this number. I don't have to multiply it with something else. Just erase this 4 and write down 6. Just erase this 4. 1 into 6 equals to 6. Now see, copper 4 copper plus 2 copper, 6 copper, 6 copper. Reactant product equal. Now we have 2 oxygen and we have 2 oxygen. We have 1 sulfur, we have 1 sulfur. And finally the equation is balanced. Done? Now I'm giving you a homework for this BaCl2 plus Al2SO4 thrice. Just take differently, okay? Just make a table. I'll make a table for you, okay? Now beta, you have to see which is the metal. Aluminium is the metal, right? Barium is also a metal, okay? Then non-metal what? Chlorine is the non-metal, sulfur is the non-metal, and at the end we will balance oxygen. Just write down the reactant, the number of elements in reactant, the number of elements in product, and just try to balance them. Make sure to check that while you balance, did you unbalance, did something else, and go back, balance that as well. Done? So at your level, it will be not that hard. It will be easy peasy. Okay, so go and try that. Now, one more I have that I will do. Okay. Okay, not last. I have so many more questions where we will balance the reactions, and these are the NCERT questions, the repeated questions. So make sure you sit down, get a copy and practice with me. Okay. Okay, now beta, we have PbNO3 twice. So of course I will write Pb, then nitrogen, and then oxygen. Done. Okay, now on the reactant side, how many PBs? Leads are there? Only 1, ma'am. Okay, in the product side, again, one lead is there. Very good. Nitrogen, see this 2 is with whole NO3. So, 2 nitrogens are there. 2 nitrogens are there. Okay, so 2 nitrogens are there on the reactant side, and then beta only 1 nitrogen is there on the product side. Then we have 3 into 2, 6 oxygens are there on the reactant side, and 2 plus 2 plus 1, 5 oxygens are there on the product side. You need to balance this. Okay, do it with me. I'm doing here. You try to do yourself and let me know if you did it faster than me or not. Okay, PB we don't have to balance. Nitrogen is 2 on the reactant side, 1 on the product side. So I will just multiply 2 with here. 1 into 2 will be 2. So nitrogen is balanced. But in trying to balance nitrogen, we unbalanced oxygen. Now how many oxygens are there? 2 into 2, 4, plus 2, 6, plus 1, 7 oxygens got there. There are 7 oxygens now in this particular equation. Now what will we do? There are 7 oxygens, there are 6 oxygens. What will we do? Ma'am, PB is balanced, nitrogen is also balanced. 2 nitrogen is here, 2 nitrogen is here, and oxygen we have 3 into 2, 2 oxygens are here, and here ma'am 4 oxygen, and 4 plus 2, 6, 7 oxygen. How will we balance this? So, what can I do? Think about it. What can I do? Okay, let me think. What if I multiply this whole equation with 2? Just listen to me. This whole equation with 2. We are also doing hit and trial method. Okay, are you able to solve this or not? We are also doing hit and trial. Don't worry. Okay, so now how many oxygens are there? Ma'am, 6 here. If you multiply that with 2, that becomes 12. Now we have 12 oxygens here. 12 oxygens here. Okay, done. And if I have to make here the 12 oxygens, what will I do? Okay, now in attempting to balance this oxygen and oxygen, we unbalanced PB and nitrogen as well. So nitrogen here is what? It is 2, 2 and 2. 4 nitrogens are there on the reactant side, right? So here I will not multiply it with 2, I will multiply it with 4. Right? So that becomes 4 nitrogen is here. Now into 4 nitrogens are here. But I also have to balance lead as well. So I'll multiply this lead with 2. Okay? So I'll multiply this lead became 2. So I will multiply this lead with also 2. Now how many oxygens are there? See, 4 into 2, 8. 8 plus 2, 8 plus 2, 10. 10 plus 2, 12. Okay? So this got cut and 12 oxygens are there and everything is balanced now. Did you see how we did it? There was a very big mistake. Not mistake, there was a very big hurdle. We had to cross here 6 and 7. How will we balance this? So what we did, we used our brain a little bit. So we said, okay, let me just see if I multiply 2 here, what will happen? 2 PB, lead is balanced. 2 into 2 in nitrogen, 4 nitrogen is there, 4 nitrogen is there, balanced. 3 into 2, 6, 6 into 2, 12. 2 plus 4 into 2, 8, 10 plus 2, 12 oxygens are there and they are balanced. Done? Understood? And that's how you will think when you stuck at somewhere. Okay, you try to think out of the box. Done, beta? Okay, very good. Now beta, let's move on to okay, let's do the chemical rest of the balancing after a little while. Okay, done. Now beta, there is some general information that whenever we write chemical equations, okay, how do we make it more informative? By information I mean that I have iron, okay, but what is this iron? What is the state of this iron? Is this an iron solution? Is this a solid iron? Is this the iron nails? Is the powder? What is it? That's what some symbols, some specific information is given to us to use so as to make our chemical equations a little bit more informative, right? What is that? Beta, the physical state of the reactants and products can be represented by using the symbols. What are those symbols? Beta, S for solid, L for liquid, G for gas, and AQ. AQ for aqueous solution. Then aqueous solution is different from liquid, yes, and we'll understand how. Just wait some time. Okay, the word AQ, okay, we'll see now here. I've written only here. Okay, the word aqueous is written if the reactant or product is present as a solution in water. If it means that you are doing some reaction with salt, but salt is in water, so it will be salt solution, and you will call it, you will write AQ. AQ beside it. Okay, that's the whole thing. What is there? Okay, 2Na. Now Na is in solid form plus water is in liquid form. Now from this we get NaOH. That means we have a reactant, a product that is mixed in water, and that's why we write it as AQ, that is your aqueous solution, plus H2 is released, that is beta a gas. That is a gas. Done? Okay. So one more thing is very important. Precipitate. Precipitate beta is something when you put chalk in the water. What happens? And you let it stay for some time. What happens? The chalk, it gets assembled in the bottom, right? It gets down at the bottom. So what will we write? When you write chalk, you will write down a downward arrow with it. A downward arrow presenting that it got precipitated, that it got it sat down at the bottom after the or before the reaction. Okay, can be also represented by using an arrow pointing downwards instead of using symbol S or solid. Then beta, gaseous state. This hydrogen is a gas that will go up, right? So this gas can also be written with an arrow upwards. Okay, so gas state of an evolved gas can be represented by using an arrow pointing upwards direction instead of using the symbol G. Then that's the whole point. That is general information how to make a chemical equation more informative. Okay, so as when you writing a chemical equation, you will write the examples, right, in the chemical equations. So in that this will help you. Done? Okay, next beta, we have finally the second section of this chapter, types of reaction. Beta, there will be different types of reactions. When we talked about T, you are combining so many reactants and only one product is being formed, that is your T. But is it actually one? You get the precipitate as well. Precipitate that settles down, the T that you filter out. Right? So what are those? There are so many different kinds of reactions, and we named all these reactions based on the number of products used, the number of reactants used, the number of reactants became. So all these things, we categorized our reactions into 4 different types. What are those? First is beta, combination reaction, and I think the name is pretty clear to tell us what is a combination reaction. Then let's understand one by one. Now beta, again we have T. Now combination reaction in T, you are doing what? In T, you are getting so many ingredients, tea leaves, milk, water, jaggery or elaichi, adrak. Sorry. So you are combining all these 3 and a single product is being made, that is your chai. Done. So what is the combination reaction? A reaction in which 2 or more reactants, they are combining together to form a single product, that is your chai. A single product is called combination reaction. That means in which our reactants are combining to form a single product. Simply, that is your combination reaction. Done? Okay, now beta, about this combination reaction we have some examples, very important, which will definitely come in your exams, and it can come in your PD test half yearlies as well. Okay, so we have to learn some of these examples. First is burning of magnesium ribbon. What is that? But it's simple magnesium. Okay, we have a ribbon of magnesium, right? And we place it in air. Just air, nothing else. We didn't give it heat, we didn't give it anything else. If you just place magnesium in the air, what will happen? It will become MgO. So what is happening? Mg plus oxygen from air are combining together to form MgO, magnesium oxide. Magnesium oxide plus some of the heat energy. Okay, now in combination reaction you have to remember one thing, that it's the reaction in which mostly heat will be generated. Heat will be generated mostly. Okay, mostly. Done. So this is the reaction in which heat will be generated. So magnesium combining with oxygen from air gives us magnesium oxide plus heat. Now this magnesium oxide beta is of white color. That is a very important detail you have to remember. Now beta, they can ask some questions on the characteristics of this reaction. What are those? Magnesium burns with dazzling white flame. So white flame, it is so white that, okay, when you look at sun directly with your eyes, you get this flash, and then you look at somewhere else, you are not able to see for some time properly, right? That's what happens when you look at this dazzling white flame when magnesium burns with oxygen very close to your eyes. Okay, and a white MgO powder in watch glass is formed. Okay, heat energy releases, so temperature increases. Obviously heat is releasing, so temperature is increasing, and this beta is your combination reaction. Plus, in whichever reaction heat is releasing, heat is exiting. We will study about this properly, but in whichever reaction heat is exiting the system, that is called exothermic. Thermic is thermal heat, right? And heat is exiting the system, that is called exothermic reaction. Okay, so this is the whole equation and its characteristics. Now some of the questions based on this reaction can be asked. Okay, why do we rub magnesium with sandpaper? Now beta, what happens is we want pure magnesium, right? But magnesium, if whenever it gets in contact with air, it turns into MgO, right? So a layer of MgO is deposited on the surface. So to remove that layer and to get pure magnesium under it, we rub it with the sandpaper. To remove any layer of magnesium oxide already present on magnesium ribbon, we rub this magnesium ribbon with our sandpaper. Okay, done? Why to keep magnesium ribbon away from your eyes? Because the reaction is exothermic. Heat is releasing. So you don't want something that is releasing heat near your eyes, obviously, right? So heat is releasing, that is exothermic. It emits dazzling white light, so bright that you cannot see for a short time after looking at it. Exactly what I told you. Done? Okay. Moving on, next we have beta, another equation of combination reaction, another example of combination reaction, that is quicklime in water. Again, very important. Take out your pen and copy and write these down. Okay, now beta, quicklime is what? Calcium oxide. Magnesium and calcium are brothers. Okay, they are in same table, same column of the periodic table. So magnesium oxide, calcium oxide. Done. That is your CaO-MgO. Now this is called beta quicklime. CaO, quicklime, solid in nature. When you combining it with water. Now do you know what actually is this? This is called that white powder we use in our houses to paint. We call it chuna, right? So if you have seen, when the workers, they mix this white powder with water, they keep it for some time because so many heat is coming out of it. Why? Because this calcium oxide combines with water to finally form calcium hydroxide, that is your slaked lime. That is your slaked lime. Quicklime is what? CaO, calcium oxide. It combines with water. Then what happens? With this oxygen, this hydrogen also comes and sits with oxygen, that I want to do friendship with you. So it becomes slaked lime, CaOH twice. Now this is aqueous, a solution inside water, correct? So this is aqueous plus a lot of heat is generated. Now beta, heat is generated, rise in temperature will happen. It's also an exothermic reaction. So a lot of combination reaction will also be majorly will be exothermic reaction. Done? So rise in temperature is your exothermic reaction. Quicklime reacts vigorously with water. When we react this quicklime with water beta, the reaction is very vigorous. Okay, the reaction is very vigorous, so that's why they keep it away for some time to cool it down. It is very vigorous. Water added slowly because reaction is exothermic, obviously. Combination and exothermic reaction, quicklime is used in making cement. Okay, done. Now beta, this was your whole combination reaction. What was it? Combination reaction is simply when two or more products, they combine together to form a single product. Two or more reactants combine together to form a single product. Few things to remember. Majorly in combination reaction, heat will be released and temperature will rise, and that will be an exothermic reaction. Then there are two examples of magnesium ribbon, MgO, quicklime in water, CaO, which forms calcium hydroxide. Then magnesium combines with oxygen in air, it gives magnesium oxide. We rub it with sandpaper so that to get pure magnesium. The magnesium oxide reaction, when happens, it is keeping away from our eyes because it is a exothermic reaction. Heat is coming out and a dazzling white flame comes out, which if we see, if it is very near to eyes, we won't be able to see for few minutes. Done? And then quicklime in water, these are the characteristics. Then next beta, the second type of reaction that we are going to study today is your decomposition reaction. Now ma'am, combination reaction is combining of reactants. Decomposition reaction, have you heard the word decomposition? Where have you heard the word decomposition? Ma'am, actually we have heard that something is decomposing. The food, the bodies are decomposing. So what do you mean by decomposing? Basically breaking down. Basically breaking down. So here it also means that we have a reactant. A single reactant breaks down into number of products. That is called your decomposition reaction. That is called your decomposition reaction. Done? So what is happening beta? A reaction in which a single reactant breaks down to form two or more products. A single reactant breaks down to form into two or more products, and this is called decomposition reaction. There are three ways in decomposition reaction can happen. Now that we will move on to, but basically the first part is what? A reaction in which single reactant breaks down to form two or more products. It is called decomposition reaction. Done? Okay. Now beta, there are multiple types of decomposition reaction. That is your three type of decomposition reaction. First is what? Thermal decomposition. That is what? You have a reactant, you heated it and it broke down. You have a substance, you heated it and it broke down into certain different products. So those reactions which use the energy in the form of heat for decomposition of the reactant. So you have a reactant CaCO3. You gave it heat. You gave it beta heat and it breaks down into CaO plus carbon dioxide, calcium oxide plus carbon dioxide. Done? Understood? Thermal decomposition, those reactions in which energy is given in the form of heat to break down the one single reactant into two or more different products. CaCO3 when heated gives CaO plus CO2. Done? Understood? Next type of decomposition reaction beta is your photolysis. Okay, we have electrolysis first. First is electrolysis. Now beta, what do you understand by the word electrolysis? Electricity. So when the energy is given in the form of electricity or electrical energy is given to break down the product, break down the reactant into different products, that is called your electrolysis or electrolytic decomposition. Then these reactions involve the use of electrical energy for the decomposition of the reactant molecules. Mostly we use it in water. So water is made up of what? Hydrogen and oxygen. When electric energy is given to this water, it breaks down into hydrogen gets different and oxygen is get separated from a single molecule of water. Hydrogen and oxygen gets separated via electrolysis. So a single molecule of water is getting broken down into hydrogen and oxygen. Done? Okay, then we move on to the third kind of reaction beta, that is photolysis. These reactions involve the use of light. Now you have studied photon in your chapters light, right? So photolysis, that means light energy. When light energy is used to break down the reactant, that is called photolysis or photolytic decomposition. So these reactions involves the use of light energy for the purpose of decomposition. AgBr, when you shine light on AgBr, it gets broken down into Ag and Br different. This reaction is used in black and white photography. This is a very important point. They can directly ask you in which reaction is used in black and white photography. So you have to say photolysis or photolytic decomposition. Done. And it is same for Cl as well. So if you have AgCl and you shine the light energy on it, it will be broken down into Ag plus Cl2. Ag plus Cl2. And of course, I know by now you all are very well equipped in balancing the chemical reactions. Done? Okay, so that was all about decomposition reaction beta. Now in this decomposition we study about this electrolysis, right? This is actually, and maybe unfortunately for you, but very fortunately for science, this is a very different, a completely different topic. Okay, but a breaking down of water into hydrogen and oxygen is very valuable and useful for us as to get energy, because hydrogen is a very pure fuel. You will study in bigger classes, hydrogen is a very good fuel, very efficient fuel, and if we can get that from water, there is plenty of water on this earth, right? If we can break down that water to get hydrogen as a fuel, that is very efficient for us as countries, as world powers. Okay, so this is very important. Electrolysis, it is very important. That's why they gave a particular topic about it. So let's study about how electrolysis is actually happening. So what are they doing to break this water molecule? So what do? They take a beaker. Okay, they take a beaker and they put pure water in it. But beta, pure water is a bad conductor of electricity. Pure water is not a good conductor of electricity. Pure water is a bad conductor of electricity. When we get shocked from the water, that water is not pure. That has so many salts. Those salts conduct electricity and our body conduct electricity. But water, pure water, just H2 and O, these are not good conductors of electricity. These are poor conductor of electricity. So in this water, a few drops of sulfuric acid are added, H2SO4. Few drops of sulfuric acids are added beta, then it conducts electricity. Okay, so what happens? We put two tubes in it, cathode and anode. You have to remember this, cathode and anode. Now beta, in alphabet, which comes first? A, B, C. So A comes first, anode, C comes last. Done. And that's how I remember that anode is positively charged because it comes first, cathode is negatively charged because it comes second. Okay, just a silly way to remember stuff. Done. Now beta, anode and cathode are there. So anode is positively charged, cathode is negatively charged. So when you pass current from these, what happens? What happens? At cathode, because cathode is negatively charged and hydrogen gas, hydrogen tendency is to lose electrons. H2 will be loosed, right? It has one electron only. One electron can be easily lost, right? So it will be H2 positive. Right, so this positive will go where? Towards negative. So hydrogen gas is released at where beta? It is released as cathode. So all the hydrogen, so water breaks down into hydrogen and oxygen, and all the hydrogen that was inside the water, it goes and it hugs the cathode ray and it stick on the cathode ray. Done. And all the oxygen that is there in the water, it goes and it deposits at anode. It gets deposited at anode, or you can say oxygen gas is released at anode. Now obviously in water H2O is there, 2 molecules of hydrogen for 1 molecule of oxygen, right? So the ratio will be what? 2:1. So 2 times of hydrogen will be produced, 1 times of oxygen will be produced in a single, let's say, for electrolysis. Okay. What is the chemical reaction? Obviously, ma'am, breaking down of water. H2O, it breaks down into H2 gas plus O2 gas. Here it was liquid, right? So if we do the balancing, this will be the balanced chemical equation of electrolysis. Electrolysis is the word. Electrolysis of water is the process of breaking down of water into hydrogen and oxygen using electricity. Done. Great. Understood. Okay. Let's move on to now to the next reaction beta. That was your, let's go back. So we did combination reaction, 2 or more reactants combined together to one single product. Decomposition reaction, one reactant breaks down into 2 or more products with the help of heat, with the help of electricity, with the help of light energy. So 3 kinds of decomposition reactions are there. Done. Then beta, we come on to displacement reaction. Now I only have one example to make you understand the displacement reaction. That is what? Beta, you and your bestie was there, you and your best friend was there, and you were having fun from the small classes to now your bigger classes. You all were together, but now a new person came in your school and she's trying to steal your best friend, or he's trying to steal your best friend, and your best friend is like, you know what, I actually like her more, actually want to be with him or her. And you feel, what? So your best friend does what? Your best friend displaces you with that new person. You have a bond, but it was not strong enough. It was not strong enough. So your best friend displaces you or replaces you, displaces you out of the picture, and the new person came into the picture, and now they are a good bond. And sorry, but you are left alone. I hope that does not happen to anybody. So beta, that is what displacement reaction is. Just replace these people, these best friends with the product, with our elements. Okay, so beta, a reaction in which a more reactive atom or element, the third person that came, that is more reactive. Okay, so a more reactive atom or element displaces a less reactive element from its compound. You and your best friend were in a good bond, in a good compound, but you were less reactive. Okay, so your best friend, this third person, it was more reactive, so it got and it sat with your best friend, displaced you, and throw you out of that compound or the picture. Okay, that's it. That is what a displacement reaction is. Okay, so a reaction in which, this is very important, a more reactive atom or element displaces a less reactive atom or molecule, atom or element from its compound. Done. So B and C were forming great compound. They were having good friendship. Then A comes and A looks at B and goes, I want to be with C. So he throws B out of the picture and go and sits with C. Now A and C are a good compound. B is bichara left alone. So A is what? A was more reactive, right? And B was beta less reactive. B was less reactive. Done? Understood? Okay, good. Now beta, for instance, we are taking an example. When iron is added to a copper sulfate solution, it displaces the copper metal and we get iron sulfate solution or iron sulfate as the product. We'll see that in the next slide. I have that. So the above reaction exists when A is more reactive than B. A should be more reactive than B. That is the core of displacement reaction. So beta, Zn combines with CuSO4. Okay, Zn comes and sees CuSO4. I wants to be with SO4. So it kicks copper out because it is more powerful. So it kicks the copper out of the compound and becomes a compound ZnSO4 plus copper. ZnSO4 plus copper. Why it happened? Because Zn beta is more reactive than copper. Done? Zn is more reactive than copper. Let me not erase this. Let me just erase these random lines I made. Done? So Zn is more reactive than copper. That is why it replaced the copper element from its compound of copper sulfate. Done? Now beta, some of the other examples of displacement reaction we'll see in a bit. I'll give you a chart. Okay, so you'll have to tell me which one is displacement, which is double displacement. I have that. That's a very fun activity. So be there. Now beta, talking about double displacement. What is that? Now you are like, okay, my best friend replaced me. It displaced me from with the other element or other person. Now I will go to the best friend of this person who displaced me and I will make a bond with them. So what happened? A and B had a bond. C and D had a bond. And B was like, okay, you know what, A, I don't want to be with you. I want to be with C. So B goes and become a compound with C. And now A is like angry. Okay, if you took my best friend, I will take yours. So now A combines with D. So what happens? This B displaced A, so A also displaced C. So what happens? Double displacement reaction happens. What happens? Double displacement reaction happens. Done, beta? That is the whole core of double displacement reaction. So a reaction in which two different atoms or group of atoms are displaced by other atoms or group of atoms. These reactions generally occur between two ionic compounds in the solution. So beta, you have a solution and you have Na2SO4 in that beaker plus BaCl2 in that beaker. So what happens? Na will say, I don't want to be with SO4 anymore, I want to be with Cl. So what happens? In that same beaker, Na combines with Cl, NaCl, then Ba is like, sulfur is sad. So Ba is like, okay, I'll sit with sulfur oxide. So that becomes BaSO4. Understood? So double displacement reaction happened. Then what happens? Reaction between barium chloride, BaCl2, and sodium sulfate solution, Na2SO4, it gives beta BaSO4, Ba goes to sit with SO4, Na sits with Cl, BaSO4 plus NaCl is your final compound. Done? Understood? That was the 4 reaction we were going to study today. What was that? Combination reaction. Lots of 2 or more reactants combined together to form a single product. Then decomposition. One product breaks down into 2 or one reactant breaks down into 2 or more products. Decomposition. Displacement reaction, when one reactant or one element displaces another element from its compound to make a different product, that is displacement reaction. Or when 2 different group of atoms or group of atoms, two different atoms or group of atoms, okay, they displace kind of each other, okay, they displaced other atom or group of atoms. These are called double displacement reaction. Then you have to, now what you have to remember, you have to remember their definitions, and at least one example of each, but in combination reaction we studied those questions are very important. Quicklime, okay, with water, and what, magnesium with air gives magnesium oxide, quicklime with water gives slaked lime, plus heat as well, okay, done. So these are the important parts of this particular, these are the main 4 reactions of this particular chapter. But beta, there are some more reactions as well, okay, there are some more reactions to it as well that we will study right now. But before that, there is a very important difference we have to study, that is displacement reaction and double displacement reaction, okay. Look at this very carefully. What happens beta? Displacement reaction, a single displacement reaction is a chemical reaction it is a chemical reaction in a more reactive element that replaces a less reactive element. This AB, in this A is replaced by C, so C is more reactive than A. Done? Understood? Basic of it. Double displacement reaction is a chemical reaction in which two ionic species are exchanged between two molecules. Simple definition, two ionic species are exchanged between two molecules. Done. So A and B, A goes and sits with C, B goes and sits with D. So they displace each other now, okay, they are in revenge mode now. Done. Now beta, in this displacement reaction we studied about precipitate. I talked to you about chalk, right? So something that sits down at the bottom. In displacement reaction, precipitate is formed as a result of color change. No precipitate is formed in displacement reaction, but in double displacement reaction precipitate is formed. Something, two compounds that are displaced, a new compound that is formed, one of them sits down at the bottom. Hence, one of the examples of double displacement reaction is precipitation reaction. Understood? This difference is beta again very important. So please go through it. Done? Okay. Next beta we have precipitation reaction, the one we were studying right now. Now again precipitation reaction occurs when these cations and anions, what we did beta, we studied in this, see, we studied in the double displacement reaction that it happens in the solution. Generally it happens in the solution. Now beta, you have a solution, right? Precipitation reaction is specifically for aqueous solutions, okay. What happens when cations that are positively charged, anions that are negatively charged, they are in a solution, they combine to form an insoluble ionic solid. They form an insoluble, whatever is insoluble, it will not get soluble in that solution, right, and it will settle down. So it is insoluble. Whenever cations and anions, they are combined to form an insoluble ionic solid. Ionic solid is called a, that solid beta that sits down is called a precipitate, okay. For example, reaction between silver nitrate AgNO3 plus NaCl and sodium chloride NaCl gives a precipitate of AgCl. When this combines, this Ag, it wants like, Na, go away, I want to sit with Cl. So it goes and sits with AgCl, but now it becomes a precipitate. It is not soluble in the solution, so it sits down, AgCl sits down, and this Na then goes with NO3, of course, and NaNO3 becomes, that is liquid, that is soluble in the solution, but AgCl, that is insoluble in the solution. Done beta? Reaction between barium chloride, one reaction we studied last time as well, right? BaCl2, when it combines with Na2SO4, what we saw, it becomes NaCl. NaCl is common salt, you can remember this reaction. So Na wants to be with Cl, so Ba goes with SO4, so becomes NaCl plus BaSO4. But this BaSO4 beta, this is the precipitate, so it sits down at the bottom of our solution and it is insoluble. Done. That is the whole thing about precipitation reaction. Then beta, moving on to some of the few reactions, we have exothermic reaction. Ma'am, what is exothermic reaction? When you are very angry, you can see your head is like hot, right? So why? Because a lot of anger is coming out of you, lot of heat is coming out of you. That is exothermic reaction. So when heat is exiting the solution or the reaction, after the reaction or from your head, when heat is exiting, exothermic reactions are reactions in which energy is released. Energy is what? Energy can be, here we are energy talking about heat. So energy is released during the reaction, meaning that the surrounding have more energy than they started with. Now beta, this is a beaker and a lots of heat is coming out. So before the heat was coming out, the temperature was 20 degrees Celsius. After the heat came out, obviously the temperature will increase. So let's say the temperature increased to 25 degrees Celsius. So what does that mean? These are surroundings, okay? Whenever you go near the stove, you can see that that whole area is very hot. Okay, so why is that? Because heat is coming and it is making the surrounding more heated than it was before. That means now surroundings have more heat energy or more energy than they started with, than before this reaction, right? So that the surroundings have more energy than they started with. And of course, there is an increase in temperature. There is an increase in temperature. And what did I tell you before? Combination reactions, when two or more reactants are combined to form a single product, energy is released. Energy is released. So those combination reactions are mostly beta exothermic reactions. Generally, combination reactions are exothermic in nature. They are exothermic in nature. That means heat is coming out, exiting. Exothermic. The exo, you can remember that exit. So heat is exiting that system. That is called exothermic reaction. Done? Some of the things about exothermic reaction, examples about exothermic reaction are beta what? Combination reaction. First is burning of natural gas. So natural gas is what? CH4. It burns with oxygen, right? So whenever it burns with oxygen, it gives carbon dioxide plus water, and it also gives heat. Burning of natural gas. Burning means exiting of heat, exothermic, right? Similarly, beta respiration. Whenever you our body is continuously doing the process of respiration, we study in life processes, right? So what is happening? C6H12O6 combining with oxygen, it is making carbon dioxide plus water plus energy that I am using to do all these weird gestures. So that is the energy. Or decomposition of vegetable matter into compost. Whenever you see a compost, you will feel like that is heat. That is heat. Okay, it's a little bit hot. So why? Because it's an exothermic reaction, because the heat is coming out of the system. When heat comes out of the system, you will see an increase in temperature of the surroundings. Done? Understood? Okay. Now, I think you can easily decipher the definition of endothermic reaction, right? Exiting means exothermic. Entering a system, heat entering a system means endothermic reaction. So, whenever energy is entering a system, it is called endothermic reaction, or energy is absorbed by the system, it is called endothermic reaction. Done. So endothermic reactions are reactions in which energy is absorbed during the reaction, meaning that the surroundings now where did this system got the energy from the surroundings, right? So surroundings gave its energy, so surrounding will have less energy now, so surroundings will have less energy than they started with. Done, beta. Okay, there is a decrease in temperature. Of course, if a molecule here gives its heat energy to inside molecule, it will go to a lower temperature, right? So temperature will decrease in endothermic. Generally, decomposition reactions in which one single reactant is breaking down into two or more products. To break down, we were giving the energy. Remember, we were giving light energy, we were giving electrical energy, we were giving our heat energy. So we are giving the energy to the system. The energy is entering into the system. So it is endothermic reaction. So your decomposition reactions are your endothermic reactions. Done. The examples of endothermic are they include thermal decomposition reaction and electrolysis, just like we talked about. Done. So these are your endothermic and exothermic reactions. Next, moving on, beta, we have some very important topics, and these topics are so important in your +1, +2, PU1, PU2 as well, and even after that, if you take on science field, the oxidation and reduction will not leave your way. Okay, but these are very easy if you understand them properly. Okay. Now beta, oxidation basically means addition of oxygen. What is oxidation? I will write it down separately so that you can understand properly. Okay, beta, oxidation is addition. They are addition of oxygen. Very first thing, whenever you see oxidation, you means that it is the addition of oxygen or loss of hydrogen, removal of hydrogen. Why did I write lose? Okay, removal of hydrogen. Okay, one more thing about it, very important, that in oxidation, sometimes we don't see, every reaction does not have oxygen and hydrogen, right? So then what will we see? That oxidation, is it reduction? How will we see it? We will see that whenever electrons are losing from that particular amount, loss of electron happens. That is also oxidation. Okay, let's come back to it. See beta, addition of oxygen, carbon plus O2. So in carbon, we added the oxygen, right? So that becomes CO2. Removal of hydrogen, loss of electrons. What happens? Zn was there, okay? Zn was there, but now it is Zn 2 positive plus 2 electrons we took out from Zn. So what happens? Oxidation of Zn happens. That's how you say it. Beta, in reduction and oxidation, one of the main things actually is how to say these things. Oxidation of zinc happened, removal of electron happened, addition of oxygen happened, removal of hydrogen happened. All this is what? Oxidation, right? Now beta, in this, increase in oxidation state happens. That means here the oxidation state was what? 0, and now the oxidation state is what? +2. So oxidation state did what? It increased. So increase in oxidation state means oxidation happens. Done. Okay, now comes a tricky part, that is your oxidizing agent. These beta are those substances which can oxidize other substances. Let's say, what do I mean by that? Okay, when I say that Zn lost electrons, so Zn plus 2 electrons. So from Zn it became Zn plus 2, it lost electrons, so oxidation happens. But it won't lose electron on its own, right? Maybe I am giving some heat or light or whatever I am giving, or I added an element A. I added this element A. Okay, now because of this A, Zn lost electron, right? So A is what? A helped to oxidize zinc. A helped to oxidize zinc. Because of A, oxidation of zinc happens. Let me write it down. Because of A, oxidation of zinc happens, right? Oxidation of zinc happened, or because of A, zinc was oxidized. Both are the same, both have the same meaning. Okay, because of A, oxidation of zinc happens. Because of A, zinc was oxidized. Okay, so A is what? A is an agent, right? A is an agent which is making zinc oxidize, which is helping zinc to oxidize, which is helping in the oxidation of zinc. So A helps zinc to oxidize. So A will be what? An agent. And what is this agent trying to do? Oxidation. So A is beta oxidation agent or oxidizing agent. Oxidizing agent. Why? Because it is oxidizing zinc. It is making zinc lose electrons. So zinc, on zinc, oxidation is happening due to what? A. So A is an agent that is helping zinc to lose electrons, helping zinc to do the oxidation. So A is what? Oxidizing agent. Now beta, see, okay, we'll study about reduction first, then I'll tell you this. So basically, what is this? Oxidizing agents are those substances which can oxidize other substances. These can oxidize other substances. Done? To do so, it will have to gain electron, hence it will be reduced. You will understand this point in 2 minutes. Okay? Next beta, first understand reduction. Now reduction is just the opposite of oxidation, right? It's the addition of hydrogen, or it is the removal of oxygen, right? In oxidation, loss of electron was happening. In reduction, we will be seeing the addition of electrons or gain of electrons will be happening. Done? Gain of electrons will be happening. So in reduction beta, what is happening? Addition of hydrogen, carbon. In that we added oxygen. Here we are adding hydrogen. It becomes CH4. Removal of oxygen, gain of electrons. Cu plus 2 electrons become Cu. Say we just have Cu plus 2. Cu has 2 less electrons. We added 2 electrons in Cu. In Cu plus 2, it will become Cu, right? So what is happening? Gain of electron is happening, addition of electron is happening, right? Gain of electron is happening. So that is our reduction. Okay? Now beta, let's come back to again, this is decrease in oxidation state. Here it was plus 2 oxidation state. Here it was 0. So of course 2 to 0, it's a reduction in oxidation state, right? Now beta, understanding reducing agent, just like we had an oxidizing agent, the one which is helping other substance to get oxidized. Reducing agent is worst. It is helping other substance to reduce. It is helping other substance to get reduction, right? So what we had? Cu plus 2 electrons, they give Cu. So what is happening? There is an agent now. Okay, now the agent is B. Now this agent is making Cu to gain electrons. This agent actually is giving these electrons. How will we say it? This agent, this 2 electrons will come from somewhere, right? Where did it come from? Agent B. Agent B provided us these 2 electrons. So agent B helped copper to get reduced. Agent B did the reduction of copper. So what is agent B? It is an agent which helps in reduction. So this will be reducing agent. Why? Because it is helping the other substance to get reduced. Done. Now beta, see carefully. When this B is giving electrons, copper it is gaining electrons, but B is doing what? B is losing electrons. Losing electron is what? Oxidation. So technically here on B, what is happening? Oxidation is happening. On Cu, what is happening? Reduction is happening. So that means whatever this reducing agent is, on this reducing agent, oxidation will happen. Let's see what's written. Reducing agent are those substances which will give electron and will be oxidized. They will give electrons, they lost electrons and they get oxidized. Similarly, come back to oxidation. What happens? So it will have to gain electrons. That means beta, this Zn plus 2 gave 2 electrons. Where will this 2 electrons give? This A will gain these 2 electrons. A will gain these 2 electrons. So A is gaining electron. Why? What happens when we gain electrons? Reduction happens. So A, which is actually an oxidizing agent. Why? Because it is oxidizing zinc, but itself it is getting reduced. Why? Because it is gaining electrons. Understood? You will have to go through it once or twice, but understood what I'm trying to say. There is a difference between oxidation, oxidizing agent, reduction and reducing agent. Done? And I hope this is clear with all this. It will be. Okay. Now let's move on to the redox reaction. Now beta, if you see that this particular reaction, what is happening? This whole reaction is Cu plus 2 plus B. Okay, this is the whole reaction, Cu plus 2 plus B. So what is happening? B is giving electrons, so Cu is gaining electrons, plus B is losing electrons. So what? At this part, Cu to Cu plus 2, we are gaining electrons. That means reduction. Right? But at B, 0 to plus 2, we are losing electrons. That means oxidation. So in a single chemical reaction, we are having reduction and oxidation as well. And that is what beta, a redox reaction is. That means a reaction in which both oxidation and reduction are happening simultaneously is called a redox reaction. That means one thing is gaining electron, one thing is losing electron. Understood? So Fe plus O2 with water gives us Fe2O3. So at Fe, what is happening? Oxygen is being added in Fe, right? So our oxidation is happening. O2, in O2, this is 0 oxidation state, right? But here the oxidation state is plus 2. So what is happening? Reduction is happening. 2 minus. So what is happening? Reduction is happening, right? So that is the whole essence of reduction, that redox reaction, the whole process of redox reaction. That means oxidation is happening and reduction is happening. So the redox reactions can be split into 2 half reactions, okay? Namely oxidation on half reaction where oxidation takes place, okay? And reduction in the other half reaction where reduction takes place. Done beta? That is the whole process of your redox reaction. The whole process of redox reaction. Done? Now there are some topics that are left to learn, and before that beta, okay, let's do this, the topics, then we'll do some very good questions. Okay, effect of redox reaction in everyday life. Now I know you have seen corrosion, you have studied about it, But how to write it in the paper? Do you know that? That is the important part in your class 10th. Knowledge is important, but marks are also important, right? So beta, corrosion beta is the process of slow degradation of the metals due to the attack of atmospheric gases, moisture, acids, etc. on the surface of metals. So if you have seen, you might have some metallic doors in your house. Mainly the main gate of the house is made up of doors, okay, it's made up of metals. So what is happening? Beta, that metal is constantly in contact with the sunlight, in so much gases, with so much dust particles, with water when it rains, right? So much gases are out there, oxygen, hydrogen, nitrogen. So when all these gases come together, they sit on the metal surface, it corrodes them. Have you seen that brownish part on the metals where it is degrading, the scraping of the paints, and underneath you see brown part? That is corrosion. And why it happens? Due to the attack of atmospheric gases, moisture, acids on the surface of the metal, and this is called corrosion. Okay, but this is a natural process. Okay, nobody can stop this, nobody can stop the gases. So this is a natural process which converts a refined metal into its oxide. It converts, very important point, it converts a refined metal into its oxide, its own oxide. Done? That is called corrosion. It can also convert it into hydroxide or sulfide. So iron forms reddish brown colored. We've seen this, right? We have seen these iron chains, right? We might have some swings in our houses, or in parks we have seen there are this brownish part on those chains of the swings, right? So that is what? That is corrosion. That is iron. Okay, it was perfect when it was new, it was perfect. Then it forms reddish brown colored coating on its outer surface due to the attack of gases, water, moisture, acids, and all that stuff. Okay, so that beta is your corrosion. Okay. Now, this how to prevent the corrosion is our main point. Okay, I'll read corrosion. What's the point of reading corrosion if I don't, correct it, right? So, what are the methods to prevent corrosion? One of the main beta is coating. What? The process of corrosion can be prevented by applying a layer or a coat of non-corrosive metal. There are some metals which are safe from these gases. So what we do on the iron that is not safe from the gases, we coat that metal. So iron is protected. It is not in direct contact with the gases now, but the metal is, and that metal does not care about the gases, and it does not go bad. On the surface of metals which must be protected, the metals can be coated with epoxy. We are hearing about epoxies today a lot, right? So many people I've seen on Instagram, they are preserving flowers and all that stuff. So that epoxy and acrylic to reduce the corrosion, because these things beta, these are not affected by corrosion. Done. Next beta, we have oiling the surface. Whenever the corrosion happens, before that, if you oil that surface and you do it regularly, you grease it, you oil it, then there is a protective layer that oil makes on the metal to protect it from the gases, from water, moisture, acid. So the corrosion of metal can be prevented when their surfaces are oiled or greased. Or painting. Painting can also help in the prevention of corrosion. Paint must be applied regularly to do this. We know paint also gets bad, right? Because it gets scraped, it gets bad with time. So we have to apply paint again and again after few years to prevent this corrosion. Done? Next beta, moving on, we have one more method, that is galvanization. What is galvanization? It's simply beta the method of protecting iron or steel from rusting by coating them with a specific element, that is zinc. That is a layer of zinc. Now galvanization, this can be asked in the question paper. Why? Because it is very specific, right? So they ask you about write two methods to prevent the corrosion. Okay, write one specific method, or they can simply ask what is galvanization. So this is very important. Make sure to remember this, that to prevent the iron and steel from corrosion or rusting by coating them with a layer of zinc is called your galvanization. Done? Okay, great. Next, moving on, beta, we have another effect of redox reaction in our daily life, that is rancidity. Now, have you seen food going bad? Right? Have you seen the food, the yeast, the fungus is there on the food? That is what? That is rancidity. And due to that, we get a foul smell, we get a foul taste, and they are not healthy to eat. So whenever food goes bad, due to the oxidation of oils, every food somewhere or there has oils in, especially Indian homes, right? We use oils. So when that oil is kept in gases, it reacts with oxygen and other gases, it gets oxidized. So due to the oxidation of oils and fats present in our food, the rancidity, that means our food goes bad. Okay, so rancidity refers to the spoilage of food in such a way that it becomes undesirable and unsafe for consumption. It is characterized by unpleasant smell and taste. Obviously, the term rancid applies to oils and fats. When food scientists talk about rancidity, they are often talking about the type of rancidity in which food is damaged due to the oxidation. Okay, the oxidation of these fats and oils. Thus, it is also termed as oxidative rancidity. How to protect this rancidity? You can use of antioxidants to prevent oxidation. You can use antioxidants. And say antioxidants are the substances that prevent oxidation. Use of nitrogen gas. You know, we all know in Lay's, when you open it, there is some gas inside. That gas is what? Nitrogen gas. That is added during the packaging of the potato chips to prevent oxidation of fat and oil, as it is an unreactive gas. So it prevents the potato chips to go bad. Okay, then beta, you can use airtight containers to prevent the direct contact with the outside air. Right? Preserving food in airtight container reduces its exposure to oxygen and thus slows down the oxidation process. Obviously, use of refrigerator. Keep the things in the refrigerator. It slows down the rancidity. Of course, things go bad in refrigerator as well, but not as quickly as it goes in the outside. Right? So that is the main thing about reduction. Then beta, we have some questions. Now here, your chapter is finally over. We will do some questions now, some of the MCQs and some of the balancing reactions, because I know that is what you really want. Okay, we all get stuck in the balancing part, so we'll do 2 more questions on balancing. These are very important and a little bit tricky. Okay, so make sure you get your pen and copy, but before that, let's see some numericals. Okay, all of you answer down in the comment section with the slide number. What is the slide number? Slide number is 53. Slide number 53. Okay, a dilute ferrous sulfate solution. Okay, FeSO4 was gradually added to the beaker containing acidified permanganate, KMnO4. Okay, Fe2SO4, sorry. Fe2SO4 permanganate, the light purple color of the solution fades and finally disappears. Which of the following is the correct explanation of this observation? KMnO4 is an oxidizing agent, so it oxidizes FeSO4. Okay, we are talking about ferrous sulfate. Yeah, so I was correct. I got confused. Ferrous sulfate, FeSO4. FeSO4 acts as an oxidizing agent and oxidizes KMnO4. The color, okay, this is the C part. The color disappears due to dilution. No reaction is involved. KMnO4 is an unstable compound and decomposes in the presence of FeSO4 to a colorless compound. Now, what do you think is happening? Beta, actually, when we have this KMnO4, okay, this has manganese ions, right? Manganese ions. Now, what this does now, this has Fe ions, right? It has Fe ions. So what this does, beta, this Fe ions, it oxidizes this. This have Fe plus 2 ions. So it oxidizes Fe plus 2 to Fe plus 3. These manganese ions of KMnO4, it oxidizes Fe plus 2 ions into Fe plus 3. And that is why the color change happens. And that means this, what is oxidizing? Fe is oxidizing, right? Who is oxidizing Fe? Mn or KMnO4 is oxidizing Fe. So KMnO4 is what? It is an agent that gives the oxidation to Fe. So this is an oxidizing agent. So KMnO4 is an oxidizing agent. It oxidizes FeSO4. So A part is your correct answer. Okay. So A is your correct answer. Okay. Understood? If you have any doubt, let me know in the comment section. Done? Next, beta, we have another question. Which of the following reaction is categorized as thermal decomposition reaction? Water breaking down into hydrogen and oxygen, AgBr breaking down into Ag and Br2, AgCl breaking down into Ag and Cl, CaCO3 breaking down into CaO plus CO2. Ma'am, water is electrolysis. What is it? Electrolysis. This AgBr also, ma'am, this was photolysis. It was photolysis, and simply AgCl was also photolysis. So actually what is left? CaCO3 gives CaO plus CO2. But ma'am, I also remember that we studied it in thermal decomposition. Thermal decomposition, we gave heat to CaCO3 and it got broken down into CaO plus CO2. Done? So thermal decomposition reaction is what? D is the answer. All other two are electrolytic decomposition, photochemical decomposition. The last one is your thermal decomposition, and it is a CBSE question. So remember this. Okay. Okay. Next question, beta. Burning of natural gas is an endothermic process. Burning and endothermic in one sentence. What do you think? Reason is, beta, methane gas combines with oxygen. Methane gas combines with oxygen to produce carbon dioxide and water. To produce carbon dioxide and water. Ma'am, we don't know about reason yet, but assertion is definitely false. Burning of natural gas, how can be endothermic? It will release the heat, right? Whenever something burns, temperature will release, heat will come out, temperature will release, heat will exit. So it is exothermic. Endothermic means heat is entering. So while burning, does heat enter or does heat go out? Heat goes out. That is exothermic. So this burning of natural gas, beta, it is not endothermic, it is exothermic process. Okay. So A is false and R is, beta, actually true. So D is your correct answer. A is false. Burning of natural gas releases heat energy, so it is an exothermic process, and this is correct. CH4 plus 2O2 gives carbon dioxide plus water plus heat as well. Done. Next question we have, beta. A student took sodium sulfate solution, sodium sulfate Na2SO4, in a test tube and added barium chloride, that is what? BaCl2. Okay. He observed that an insoluble substance has formed. The color and the molecular formula of the insoluble substance is what? Beta, we studied this reaction, right? That an insoluble substance is formed. This is what first? This is a double decomposition reaction. This is a, beta, double decomposition reaction. True? So Na says I want to sit with Cl. So it goes and sits with NaCl. Plus, and I am again assuming you know chemical balancing. If you don't, the next question is of balancing. Okay, and Ba goes with SO4. So we have BaSO4. This BaSO4, beta, is an insoluble substance and it is white in color. This is an important detail you have to remember, because see, the question has come in CBSE. BaSO4 pink will be wrong, so you do have to know the color. So B will be your correct answer. BaSO4 and white color of BaSO4 will be formed. Okay. Last question from this: why does the color of copper sulfate solution change when iron nail is dipped in it? CuSO4 plus when iron nail is dipped in it. Ma'am, very easy. This is decomposition reaction. Oh, sorry. This is displacement reaction. We studied, right? Displacement reaction. Why? Beta, copper sulfate. Copper sulfate is our what? Blue in color, right? It is blue in color. But when it is added with Fe, it gives FeSO4. That is your brown in color. Yeah? What is it? Let me know in the comment section. Is this correct or not? Comment section. Let me know fast. So because of this beta, because Fe displaces copper, because Fe is more reactive than copper, then this color is changed, right? Done? Okay. And identify the substances that are oxidized and the substances that are reduced in the following reactions. Okay beta. NaO2, Na2O. Ma'am, Na is being added with oxygen. So Na is oxidized. Na is getting oxidized. Done. Then beta CuO plus H2. So Cu is releasing hydrogen. Cu is getting reduced. Cu is getting reduced, but hydrogen is gaining oxygen. So this is getting oxidized. This is getting oxidized. Understood? Great. Now, as I promised, two very good what do you say, formulas, two very good questions of balancing chemical reactions. Here we are. Okay. Now, consider the following chemical equation. Okay, they have given the chemical equation. PAl plus QH2O gives RaL2O3 plus SH2O. Now, what is this PQRS? This is simply something to confuse you. Okay, so what happens beta? To balance this chemical equation, the values of P, Q, R and S must be respectively. So you have to balance this chemical equation. Okay, just do that, then we'll come back to this PQRS. Okay, just make a simple box as we did before. Right? Now this is reactant, this is product, and we will divide it into 3 columns. Now first we will write metals. What is metal? Aluminium is our metal. Non-metal is not there, so we'll write oxygen, then hydrogen. Then we'll do beta what? We'll see the number of elements in both reactant side and product side. So in the reactant side, number of aluminiums are what? Ma'am, simply 1. In product side, number of aluminium is 2. Okay, unbalanced. Then oxygen, 1 in the reactant side and 3 on the product side. Then hydrogen, 2 on the reactant side and 2 on the product side. Okay, so hydrogen is balanced, but for now, because we know in order to balance something, we might unbalance something else. Okay, okay, so let's balance aluminium first. Ma'am, I'll do simply what? I'll multiply this one with 2, and 2 elements of aluminium will be there in the reactant, 2 will be there in the product. Aluminium is balanced, so I will write this 2 here. Okay. Then beta balancing oxygen, 1 oxygen is here, 3 oxygens are there. So I will multiply this 1 with 3 and simply 3 oxygens will be there, and I will multiply this with here. And in the balancing oxygen, we have successfully unbalanced hydrogen. Okay, so 3 into 2 becomes what? Cut this. Now hydrogen is 6 on the reactant side, only 2 on the product side. So what will I do? Easy peasy. Ma'am, I will multiply this 2 with the 3 to get 6 molecules of hydrogen. This 3 will be here to get 6 molecules of hydrogen. 2 aluminium, 2 aluminium. 3 into 2, 6 hydrogen. 3 into 2, 6 hydrogen. 3 oxygen, 3 oxygen. Done? Understood? Very good. Okay. Now, this is not where your part ends. This is where your final answer is still pending. Okay, beta, this final answer P. Now, what is this? This aluminium has P. Here aluminium has 2. So you just equate these 2 equations. Now P with aluminium, 2 with aluminium. That means value of P is 2. Okay. Q with H2O, 3 with H2O. So value of Q will be 3. Done. Then we have R with Al2O3, but here we don't have anything, only 1 is here, right? So R, value of R is simply 1. Then we have S with H2, 3 with H2. So we have value of S beta 3, and this will be your final answer. This will be your final answer of the first question. Done, beta? Then I have one more question for you, and I want you to do all the solution to that question, and we'll do one more thing where you have to see what are all the reactions given. Okay, this is the another example, exact similar example, MnO2 plus XHCl, MnCl2 plus YO2. Just make a box and you'll have to write what? Manganese, after that non-metal, chlorine, after that oxygen, hydrogen. Write down the number of elements in product side, in the reactant side, and balance them, and write the answer in the comment, slide number 16. You can simply write the values of X, Y and Z. Write the values of X equals to this, Y equals to this, Z equals to this. This is your homework. Done? Write down in the comment section with slide number 16. Okay? Now, one more thing I have very interesting, that this thing is really interesting. What you have to do, I have some chemical equations. Okay, first of all you have to learn these are very important. All of them you don't have to learn, you have to understand these. Okay, so beta, PbNO3 twice plus Ki gives PbI2 plus KNO3. What is happening? This NO3 got displaced by K. Now see, this Pb now sits with I, so it displaced K, Pb displaced K and go and sat with I. Then K went with and NO3. What is that? What is that? Double displacement reaction. This is what? Double displacement reaction. They can ask you, they can give you they can give you to write an example of double displacement reaction, but they can also give you a reaction and they can ask you what type of reaction is this. Okay, so again this is very important. Next beta, CaO plus H2. Two things are combining to form a simple thing, and this I know, ma'am. Quick lime to slaked lime and exothermic. Ma'am, this is simply combination reaction. This is simply combination reaction, and yes, you will get all the notes in the description in the form of a PDF. Okay. Next beta, CaOH twice plus CO2 gives CaCO3 plus H2O. Can you tell me which reaction is this? Can you tell me which reaction is this? Okay, this in the comment section. In the comment section, I'm giving you some work today because we have revised this chapter, you have revised this chapter, so this is a little homework you have to do. Okay, slide number what? Slide number, this is 44. Okay, slide number 44. Third reaction. Which reaction is this? Lime water into limestone. Which reaction is this? Let me know. Okay, great. Then beta, CaCO3 plus CO2 plus H2O gives CaHCO3 twice. Which reaction is this? Ma'am, some things are combining. So this is simply beta combination reaction. This is simply combination reaction. Then fifth, we have PbNO3 twice. It is breaking down into PbO plus 4NO2 plus O2. What is that? Simply decomposition reaction. There is one single reactant and it is breaking down into two or more products, which is what? Decomposition reaction. And again, comment down which decomposition reaction is this? Is this thermal decomposition? Is this photochemical decomposition, or your electrolysis? Done? Okay, next we have AgCl breaking down into AgCl2, or AgBr breaking down into Ag plus Br2. What is this? Again, decomposition reaction. Again, decomposition reaction. And which decomposition reaction is this? Ma'am, this is actually photochemical photochemical decomposition, or we also call it photolysis. We also call it photolysis. Okay, then beta we have iron plus CuSO4. It combines to give FeSO4 plus copper. What is this? What is this? This beta is your displacement reaction. Why? Why is this displacement reaction? Why not double displacement? Because copper is alone. Copper is lonely. If he also found some friend, then it will be double displacement. Copper is alone right now, so is lonely. Is just have displacement reaction. Done. Then beta Na2SO4 plus BaCl2 give BaSO4 plus NaCl. Simply double displacement reaction. Then we have Cu plus O2. Some things are combining to form a single product. What is that? Combination reaction. Combination reaction. So you should know how to decipher and name all these reactions. Okay, and the last one you tell me in the comment section. Last one you tell me in the comment section. It is very easy. Okay, now beta, this is where our chapter finally ends. I gave you some homework, some of the questions, so make sure you revise those. Make sure you comment down so that I can know that you have revised, and this chapter is very important for your PT test, for your half yearly, and even for your boards. A lot of questions are going to come, and this is a power packed one shot I gave you. Okay, and that is it in this whole video. I'll meet you in the next one. Make sure you are fully energized and filled with josh for your boards. Tata, bye bye.